We are into part 13 of our course in software project management. So today we will discuss software testing management. Traditionally, software testing has been often a neglected area as management used to see it as a waste of dollars spent, no productive output in terms of something produced. However, with strict quality norms required these days for software products, software testing is one of the important aspects of software projects. So software testing is something which was looked upon not in good terms by the management because in software testing no nothing is being produced, it is only being tested or already built software product is tested. So from that point of view, testing does not do any production, but testing is important because if testing is not good, then a lot of defects will go in production of the software product, and users will find it difficult to use the software product. So testing actually what it does is it test the business logic and all the implementation of the requirement specifications and ensures that the product works as per the requirement of the users. So if any defects are found, they are reported and they are fixed. Only then the product is released. So testing is very important from that point of view. The other point of view is that if a untested product or not thoroughly tested product goes into production, then it will be very difficult for the team which will provide support. The support cost will be very high because the users will report defects and problems with the software product, and the support team will have to resolve those requests, resolve those aspects, and have to spend too much time. So that means uh, cost, support cost. So support cost will be very high if the software product is not tested properly and there are too many defects in the software product. Software testing involves validating a software product by comparing expected behavior with the actual behavior when tested. So testing validates a software product by looking at the expected behavior, which is uh, which derives from the requirements given by the users, and then finds if it is working as per this expected behavior. If not, then defects will be logged and fixed. Verification of the software code, on the other hand, involves doing inspection to verify that the software code is written correctly or not. So verification is one part which is which deals with uh, the verifying the artifacts which are produced during the software project. So these artifacts include the requirement specifications and design, as well as when the source code is being written, it is not integrated in the main product or main build, software build. So at this stage, all these artifacts should be verified. So verification is the process of verifying these artifacts. A separate plan for testing is prepared to ensure that proper testing is done on the project. The testing plan should include test strategy, resource planning, budget, and schedule. So, since we know the testing uh, is an important aspect, and the project team must ensure allocation of enough resources and time so that testing can be done thoroughly. and for this a test plan is created, and generally a test manager will be responsible for all testing activities, and the testing plan should include the test strategy, like how much testing needs to be done, which part of the product needs to be tested, and what could be the testing methods to be deployed, and how many uh, defects are expected, and how much uh, how effectively the testing can be done based on the information available with the test manager, and accordingly there will be a resource planning and budget and a schedule for the testing effort. So here is uh, one aspect about testing is if more than required testing is being done, like when the project team generally knows from the customer what they expect, what quality level they expect, and how to achieve that much quality level. So if the testing is done more than that level, means the more is time is being spent, more resources are being allocated than required, then it will be a waste of time and money, because the customer does not care if the product is working above the standards they are looking for. So definitely it will be a waste of time and money. At the same time, uh, generally any software products needs to be released to to the customer or users within stipulated time frame, so that they should be able to use. If there is too much time is spent on testing, so the users will not be able to get the product released, and so could not be able to use the product in time. So that is also one aspect. Then if you have less than required testing, then it will result in high cost of support, and it will be costly affair for the vendor or the customer for whom the software product is being built. And if there is no testing at all, then in that case the product will simply be cannot be used at all, because there will be too many defects and it cannot be used at all. So that is totally uh, disastrous scenario. Traditionally, testing was done very late in the software development life cycle. Like uh, uh, testing will be done only after the software has been built, all the source code has been written, and only then it will go for testing. So what happens is, if suppose there are some defects in the requirement specification, so the design will also be faulty because it is based on the requirement specification, and then correspondingly the source code will be faulty because it is based on the faulty design. And so when the product is tested at that level after the product is built, then there will be too many defects, and uh, it will be there will be too much effort required to test and fix all the defects. So they are not a good scenario. It is too late. So nowadays testing has to be done right from the beginning of the project when the specifications are created. So the specification should be tested. Then again, when the design is created, so testing should again be done. And when the source code is written, so at the unit level, like whenever a class is being built, so that class should be tested to ensure that all the business logic is implemented correctly. So that is the importance of testing. Now here is verification and validation. Generally, there are two terms used in software testing. So one is known as verification and other is validation. So what is verification and what is validation? So verification is when the product is tested not by running it, not by executing the source code. Instead, uh, it is not run at all. It is just because it cannot run. Like for example, the requirement specifications cannot run. They are only on a document. So in uh, in those scenarios, uh, the tester or the person who will be testing, say, requirement specifications, so they will see if the requirements are correct and complete, so that they, that means there are no defects. In if there is a specification which is incorrect, then it is a defect. If any specification is not complete, then again it is a defect. So that has to be removed. So that is done through testing. Similarly, for design and for construction, for the unit testing or integration testing. So these are known as verification. Validation covers the areas when the product is being built and by running it. So suppose the source code has been written and it can be run. So in that case, validation is when it is tested in running condition, then it is validation. So validation means when the you are testing a product by executing it. So unit testing will cover inside the validation. Similarly, integration testing and then system testing. So system testing is when the complete product is being tested. So that is system testing. Again, at the deployment level, when end users will start using the product. So before using the product, the end users will test the product and check if it is working as per their requirement. So these are known as validation testing. So how the testing effort estimation is derived. So there are some methods to estimate the effort required for testing, and one is known as test point analysis. So in test point analysis, first the product size is determined, generally in terms of number of function points. So generally number of function points will be available to the person who will be doing the effort estimate for testing from from the development effort, because the development effort at that stage the number of function points will be determined, and that same number can be used for testing effort estimation as well. Then test strategy. So what level of quality is needed and what are the priority areas. So priority areas must be tested in the testing effort. So that is the less priority area. If there is a time, then less priority areas can be tested. Otherwise, priority area must be tested in the testing cycle. So that information is needed to find out the effort estimate. And then productivity. So productivity can be derived from the experience and the skills of the testing team. So if you have a team with people with good experience and skills, then productivity will be high. So the total effort estimate will be derived from these three factors. Then here is the test case life cycle. So you first of all, test case is designed, and then the actual test case is written based on this design, and then if it is an automated test, then test script will be created, and then the test case is executed, and if there is if the test case passes, then it is fine. If not, then there is a defect, and then defect tracking will be done. And finally, if the defect is fixed and now the that part of the software product is working fine for which the test case was written, so this test case will be closed. So this is the entire life cycle of a test case. And inside that, the defect tracking. So defect tracking itself has a defect life cycle. So it starts when a defect is logged in a logging system, say defect tracking system. Then this defect will be assigned to a developer who had written the uh, source code, or who is now responsible for the source code. So that defect will be assigned to the developer. The developer will fix the defect, and it will be notified to the tester. So tester will verify the if the defect has been fixed. So if it is fixed, then the defect will be closed. If not, then again the defect will be opened, and again the same cycle will continue. Automation is a good resource to reduce software testing effort, but all testing activities cannot be automated. Testing activities include test case writing, test case execution, test case result analysis, etc. Test case writing can be automated for unit testing, but for other types of testing, for example, integration testing, user acceptance testing, or system testing, automation is difficult, and so manual test case writing is done. The first time a test case is run should be done manually, and so it cannot be automated. The only area open for automation is repeated test case execution. So when same test cases need to be executed many times, then those test cases should be automated. On what kind of project this scenario exists? Of course, on iterative or agile projects, newer versions of the product with new functionality added need to be tested for both new functionality added as well as the older functionality. So this is the scenario with iterative or agile projects where new functionality is added on the existing functionality of the software product, and so testing is done for not only for the new functionality but also for the old. It is important because when developers add a new functionality by writing a new fresh source code, they also need to change sometimes the old source code because they do refactoring. So if some refactoring has been done, so even though the old functionality is there, but uh, due to this refactoring, some old functionality may change. So to ensure that the old functionalities are also working as per uh, requirement, then so to ensure that you need to test the old functionality as well. In such cases, the test cases written for older features can be rerun on newer versions of the product. On such projects, test execution can be automated. So in so uh, this discussion indicates that the older features need to be tested again and again many times. For example, suppose you are in the fifth version of the product, so the old software features, some of the oldest, may have to be tested already. They have been tested already 3 times, 4 times. Now you are testing for the fifth time. So uh, those products are being tested again and again, and this is very common. Like nowadays, there are too many releases of any software product, say every month or every 2 months, something like that. And so suppose the software product is being already being developed for last 3 years. So some of the functionality has been tested how many times? Suppose 2 months means six times in 1 year. So 3 years means 18 times. So 18 times some old functionality is being tested again and again. In such cases, test automation can be done because uh, mm, writing the test case and then executing the test case and then that defect tracking life cycle, it all takes time, and especially uh, writing test cases and executing test cases can be avoided for old features by writing some scripts using some programming language, and those can be saved. So whenever some old feature needs to be tested again, you just run the test script. So this is a scenario for automation. Generally, when you are testing old features through these automated test cases, then it is known as regression testing. Software defect tracking is one area which needs attention to know which parts of the software product are failing again and again. Defect tracking is important because it shows the testing effort in terms of number of defects found, defect corrected, and still open defects. So defect tracking is the final area which needs attention because from here you can get the idea as to which software product features are failing again and again. So you can find out why it is happening, and you can take some proactive measure to ensure that they do not fail again and again. And from defect tracking also, the testing effort in terms of number of defects found, defects corrected, and still open defects, they indicate the efficiency of the testing being done and the effort required in testing. So this was all about software testing management. Next we will see software release and maintenance. So thanks for your time, and bye for now.